This is the first part of the unit on oxidation and reduction. What we're going to look at in this particular unit is a revision of reduction potentials, redox stability, and then we're going to focus our attention on the diagrammatic presentation of potential data. So what you're about to see in this particular portion of the unit, this first part, is purely revision from first year electrochemistry work that you did in Chemistry 1B. So you're familiar with oxidation and reduction. You know about what is a reductant and an oxidant, and we know about redox reactions. We know what happens to the oxidation numbers during oxidation and reduction, and we find that if no element in the reaction undergoes a change in its oxidation number, then the reaction is obviously not a redox reaction at all. We know what electron transfer is. It allows for the flow of electricity, and you're familiar with setting up electrodes and electron transfer, the standard potentials. And what happens when we study a redox reaction is we tend to study and look at the tendency of electrons to migrate from one species to another, and it's generally expressed in terms of the differences between their standard potentials. I would encourage you at this point to revise your first year work, as I could ask material from your first year work as it's a basis for what we're going to build onto. This is something that you should be familiar with, looking at a galvanic cell with a reaction between zinc and hydrochloric acid, and we know about how to split the two reactions into their half reactions, one reduction reaction, one oxidation reaction, and then sum the two together. Once again, you can go through this material in your own time. You can pause the video at any point to read what's on the slide there with you. Remember how to balance equations. That's part of your first year work. You need to go over this material so that you're familiar with everything regarding oxidation and reduction, so that when we tackle the more difficult stuff, you have a good basic grounding of what is happening. This slide just reminds you of what a galvanic cell looks like. It also reminds you of the material that we did in Chemistry 1B, where we considered the thermodynamic quantities. Remember that we took a look at the Gibbs free energy and how we can relate it to the electrode potential, where in this case nu is equal to n, if you're familiar with, is the number of electrons, okay, and F is the Faraday constant, which if I needed to give it to you, I would. When we consider the thermodynamic properties, we need to remember about spontaneity. This is all first year work. You need to remember what was the reasons that we did all of this, and remember that if we get a positive cell potential, so if the standard potential is greater than 0, then the reaction is spontaneous, and subsequently if delta G would then be negative, we'd get a spontaneous redox reaction as well. This table just shows you some of the thermodynamic contributions to the standard electrode potential for a bunch of metals. It's just giving you some information about the various thermodynamic properties. I don't require you to learn this table off by heart, but you may be required to use it and interpret data with it. And lastly, you should be familiar with reading and using reduction potentials. You're familiar with the electrochemical series. You know about strongly oxidizing materials that have very high positive standard E0 values, and similarly very strongly reducing species that have very negative E0 values. You will obviously be given this information should you be required to calculate anything, and I'll give you a table of standard reduction potentials should they be required.